All right, let's get started. We are going to talk about section 3 today, which is complex numbers or imaginary numbers. We'll talk a little bit about the difference in a second. But let's start off with just thinking about this problem right here, x squared equals -4. Now, what you've been taught up until now is that if you try to go and solve this, so you take the square root of both sides, and actually, let's back up 1 second. So if you have square root of or x squared equals 4, and you square root both sides, there are two possible solutions to this equation. There is 2, because 2 times 2 is 4. But there's also -2, right? Because -2 times -2 is also 4. So we always, when we take the square root of a variable, we do plus or minus. So we get x equals plus or minus 2. Excuse me. But with this equation that we have, x squared equals -4, there is no number, no real number, that you can multiply by itself to get a -4. Okay, if you try a negative number, it'll be negative times a negative, which will give you a positive. So we're stuck. And up until now, we've said you can't solve this equation. There are no real solutions. And many of you probably put no solution. What you should have put was no real solution. We don't usually make a big deal about that as teachers in the earlier classes. But now, I'm going to show you how I can deal with this. So in this situation, what I would end up with is x equals plus or minus the square root of -4. And what I'd like to define right now is this, the square root of -1. We're going to call that the imaginary number I. Okay? So anytime you see the square root of -1, you can replace that with I. Excuse me. And that turns out to be pretty useful. And it does have applications in reality, even despite their name of imaginary numbers. So in this situation, what I could do is I could write this solution as x equals plus or minus the square root of -1 times the square root of 4. And if I did that, then this is just I, right? Because we defined that up here. Square root of -1 is I, and square root of 4 is 2. So I could write this, plus or minus I times 2. Now what we usually do is we usually write the real number first, so our final answer would be this, plus or minus 2i. And this will have lots of applications later on in algebra, but for right now, the application is it gives us a way to deal with the square roots of negative numbers. So let's do a few examples dealing with I here and see what happens. Okay, so square root of -27. The first thing I would try to do if I was going to simplify that, and really any square root of a negative, is I'm going to write that as square root of -1 times the square root of 27. In other words, I'm taking that I out. So this then is I times the square root of 27. Let's just break down 27 real quick. Take out 3, I get 9. 3, I get 3. 3, I get 1. One pair of 3's comes out in front, so I have 3i times the square root of whatever's left over. There's 1 3 left over, and so I get 3i square root of 3. Okay, let's talk about powers of I. Now, the powers of I are really interesting because so if I just have I to the 1 power, remember that's square root of -1. Sorry, let's do this. Square root of -1 is equal to I. So what happens if I square that? What happens if I take I and I square it? Well, that would be the same as squaring the square root of -1. And so what I would end up with is this number squared would be just -1. Right? If you square a square root, they undo each other, you're left with -1. What about I cubed? Okay. So actually, well, okay, that's fine. What about I cubed? Well, I cubed is equal to I squared. You know what? I'm just going to rewrite this. Sorry, I need the i's on the other side. It's going to drive me nuts. -1. So I squared is equal to -1. What about I cubed? Well, I cubed is equal to I squared times I. Well, I squared we just said was -1, so this is equal to -I. What about I to the 4th? Well, I to the 4th, that'd be the same as I squared times I squared. That's -1 times -1, that's +1. What about I to the 5th? Well, I to the 5th is equal to I to the 4th times I. I to the 4th we just said was 1 times I, so 1 times I is just I. So we get back to the beginning. This, by the way, is I. So we have I, -1, -I, 1, I, and every time that we go up a power, we can always pull I to the fourth and then whatever's left over, all right? So we'll do an example of that in a second, but the powers of I just cycle. Every 4 powers of I, we're back to I to the 1 power, all right? So let's do some examples that sort of build on that. So what about this one? We have negative 5i times 3i. Well, we always multiply the real numbers first, or at least I do. So I've got negative 5 times 3, that's negative 15. What about I times I? Well, that's just I squared. And over here we said that I squared is the same as negative 1. So I have negative 15 times negative 1. That's just 15. Okay. So this thing that looks sort of complicated just turns out to be another way to write 15. All right, let's do this one here. So now I have 2 square roots of negative numbers, and so again, before this lesson, we'd be broke, right? We'd be done. We'd be like, I can't do it, and move on. But now we know that I can write this as I times root 6 and I times root 15. And then I can go I times I, that's I squared. Square root of 6 times square root of 15 is what, 60 plus 30, so 90. So I get negative square root of 90. So this thing that seemingly is impossible to begin with using i's, we can get down to an actual, a real number, negative square root of 90. And then you could break down 90 and break this down further, but I'm not concerned about that. I really just want to show you how the i's work, right? Let's actually solve an equation where this would show up. We solved a short equation, a small equation, I guess you would say, at the beginning. How about this one? I've got 2x squared plus 32. Now, pause right here. I know many of you may not actually pause and let this sink in. We cannot solve very many quadratics in the way that I'm about to show you. Very many equations with the power of 2 on the exponent or on the variable. Excuse me. If there is no middle term, in other words, there's no linear term, then we can solve them in this way. Okay? So I'm going to start off by moving 32 over. I get this, 2x squared equals negative 32. I'm going to divide by 2. If I am going to solve in this way, then I have to get the x squared by itself before I take the square root. Some students will see the square and try to square root right away. No, you've got to do that last. You want to get the x squared by itself first. So what I end up with is x squared equals negative 16. Now, square root both sides, plus or minus. And I get this, x equals plus or minus the square root of negative 16. Well, that's just going to be plus or minus I times the square root of 16. Oh, that's just plus or minus 4i. All right, so again, here, now this is not a real number, right? This is an imaginary number, but, or 2 numbers, I guess. But yeah, we get down to x equals plus or minus 4i. That's our final answer. Okay? 2 imaginary solutions. Now, let's talk very quickly, because it doesn't come up a lot in this section, about complex numbers. Every number you've ever dealt with is a complex number. Okay? You have been only dealing with real numbers. All right? But complex numbers include the real numbers and imaginary numbers. All right? So pure imaginary numbers is what we've been avoiding. You've been only dealing with real numbers. But complex numbers are numbers that have imaginary numbers in them. Okay? So I don't want to get too, I don't want to go into too much detail here because it doesn't matter that much. But every number with an I is a complex number. And if you have a number like 7, I would say, well, that's a complex number. And you'd say, there's no I in there. And I'd say, yeah, there is. Watch. See? It's a complex number. It's got an I in it. We just don't ever write the 0i. Okay? All right. So again, I don't want to get too hung up on that, but but we are going to do some operations with complex numbers here. So if I want to simplify this expression, then what I'm going to do first is distribute the negative through. Okay? This is just like combining like terms. If this was 5 minus 7x minus 2 plus 4x, we'd be combining like terms. It's the same idea. We treat it just like that. So I've got 5 minus 7i minus 2 minus 4i, and I'm going to combine like terms. I have 5 minus 2, that's 3. Negative 7i minus 4i, that's negative 11. I wrote an A, sorry, where that came from. Negative 11i All right, and that's it. That's your final answer. And we always try to write our complex numbers in this form, a plus bi, where the real part comes first. So this is the real part, and this is the imaginary part. Okay? All right, now, let's look at one of these. I to the 30th, all right? Now I'm going to write this out in the long way first, but you don't need to do it like this every time. But I to the 30th, that could be written like this. I to the 4th times I to the 4th times I to the 4th times I to the 4th. So that would be 16. So times I to the 4th, that'd be 20. Times I to the 4th, that'd be 24. Times I to the 4th, that would be 28. Times I to the 2nd. Okay, that will give us 30. Well, this is just 1 times 1 times 1, times 1 times 1. Let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7 times I squared. Well, that's just going to be I squared. Well, that's just negative 1. Right? We figured that out up here, that I squared is negative 1. Now, that's one way you can do it. And I've had students that do that even if it's I to the 100. They'll just write out I to the 4th a bunch of times. But the other option is you take 30, divide that by 4, and you see what your remainder is. So this would be 30 divided by 4 would be 7 and 2/4. Well, that 2 there, that's your remainder. That's how many i's would be left over after you take out 7 groups of I to the 4th. So what you end up with then is just, you can just jump to this. You can just jump to I to the 30th has to be equal to I to the 2nd because of that remainder there. And that's negative 1. That's a shorter way to do it, but you don't have to. Last one. Multiply these out just as if I had 3 plus 5x times 5 minus 3x. It would be the same process. You can FOIL it. I like the box method because it scales to harder problems better than the FOIL method. But you could use the FOIL method too. So I'm going to make a little box over here. And I'm going to write 3 plus 5i here. 3 and positive 5i, I guess I should say. 5 and negative 3i here. It doesn't matter which one you put on top and which one you put on the side. Then we're going to multiply. So we're going to go 5 times 3, that's 15. 5 times 5i, that's 25i. 3 times 3i, that's negative 3i, negative 9i. And then negative 3i times 5i, we've got to be careful here. This is negative 15i squared. Okay, negative 15i squared. So what does this end up being? Well, let's write it out. I got 15 minus 9i plus 25i, minus 9i plus 25i, and then minus 15i squared. Okay, simplify. So this would be 15 minus 9 plus 25. So that would be 16i. And then negative 15i squared. That's negative 15 times negative 1. Okay, so that would be positive 15 then, right? Because I squared is negative 1. So it would be plus 15. 15 and 15 is 30. So I end up with this, 30 plus 16i. So there's lots of little ways that we can kind of play around with complex numbers and do operations with them. A lot of it comes down to like terms, just like combining like terms, with the exception of you really got to pay attention to the powers of I, because that does change things, right? Right here, that I squared being negative 1 changed the problem in an important way that makes it different than just as if I was X. All right, and I think that's it for complex numbers.